services. Let me open one diagram for you. Right. Now, consider so far what we have seen. We have seen that whenever there is a client, right, and that client wants to access a website. So in last lecture, we have discussed about the deployment, right? So there is a deployment. With the help of deployment, what we can do, we can run our pods, right? Version V1, V2, and we have discussed about uh, the blue and green process also, right? So version V1 is updated with version V2, right? Now, that is our internal process as a DevOps engineer. So what I'm going to do, I'm going to deploy my developer's code into the production or staging or some environment so that the developers, right, so they keep, if they are updating their code, it will go to the GitHub repository or automatically build, and automatically it should be deployed in the Kubernetes, right? Now, the next point comes that how client will access this. Okay, how client will access this. Consider this is running with version V1. Your all the ports are running with version V1, right? Now you have a requirement that it should be updated with version V2 because that is the case, right? V1 is updated with V2. Okay, this process is absolutely fine for the deployment point of view. But how end user or client will access it? In that case, see, if you are running with some labels, all the pods are running with the same label because we are using the deployment, and deployment is having the replica setting uh, inside that, which basically runs your application in a high availability or load balancing way. Right. Now, the thing is that this is my client, and my client wants to access my pod, and everything which is running in the deployment case in the pod network means internal to the which is internal to the cluster. It is not available outside the cluster. That is why there is a concept of service comes into the picture. So what is service? Okay, one more problem I just want to highlight here, that consider if this client wants to access this particular pod, and if there is no any other layer in between, then what will happen? That this pod is running with version V1. Okay. Now client is able to access it. Then consider this pod is updated with version V1 to V2. So new pod when get created, so it will have a new IP address. If it is having a new IP address, then you need to change into your DNS setting that DNS setting that will be bit difficult, or maybe you need lot of efforts, manual efforts, to update this DNS so that your client should access it, which is not a realistic way to do that. Okay, we don't know, no one is doing that. Okay, if they are doing, it's really a very bad practice. So now another problem is that consider you have established one link between end user and the IP address. So right? So now, so what will happen that this if you have established a link and you are maintaining, if version v1 comes and it will be it will be updated with version v2, right? And end user can access it. But what about the load balancing? Okay, what about the load balancing? See, consider that there are a lot of traffic which is coming to this pod. So you want to distribute that traffic to other pods also. So if we are only using deployment, underneath that there is a replication controller, but for the end user point of view, right? So it will be difficult, right? Again, you need to write some custom logic to distribute the traffic. So because of all these problems, right? So we are having a solution which is provided by Kubernetes resource, and that is called the service. Okay. So now let us see how service solve this problem. So first of all, we were having a problem that there should be a static IP address, right? So service, if you are using a service, so service is having a static IP address. That is one thing. So it means if I am configuring my DNS, so what is the role of DNS? See, whenever you are accessing your application, right, you need a static IP address so that you can configure with your domain. Domain, like for example, if there is a kmitcourses.com, this is the domain, and I want it should connect with some IP address, because pod IP addresses are keep changing because of its updation process, right? So static, we need the static IP address, and this static IP address is provided by the service. That is one thing. Now, how service will transfer the traffic to these ports? So service is having something called endpoints. What is endpoint? Endpoint means the IP address which are attached to the service. So it means if you want to call a service, then it will send that send the your request to the those IP addresses. So those IP addresses are called endpoints. So but how these endpoints are basically determined? So these are determined by using labels. So this is my IP1, this is IP2, this is IP3, right? So I have three IP addresses, IP1, IP2, and IP3, which is the IP address of all these three ports, right? So now I have a label selector, which is app equals to nginx app. So this label selector is the one which will select the ports, and the IP addresses becomes the endpoint of the service. So it means now if you hit the service IP address, then what it will do? It will go to IP1, IP2, or IP3. Right? Now consider if there is lot of traffic comes to this particular service. So service has a inbuilt feature which is called the load balancer. So service is having internally a load balancer. So it means if there is lot of traffic comes, and that traffic will be equally distributed to these pods. Okay, so this is the service. So now what will happen, that if client is going to request to access a pod, then that request will go to the service, not to the pod directly, and service will take your request and access the application which is running inside the pod. It is having the endpoint, and that endpoint is That endpoint is the IP addresses of the pod. So, but the pod IP addresses are keep changing. So the endpoints are also getting changed automatically. How? Because of the label selector. Let me do one thing. Let me just show you that practically. So what I'll do here, I will go to my cluster. I'll go to Mova External and I will connect to my master node. So now right, right. So now let me just first thing I always check that whether there is my cluster is in the ready state or not. So I will log in with the root user and I will say kubectl and get nodes. So all the machines are in the ready state. Let me see something running. Kubectl get pods. There is one pod. Let me delete that. Kubectl delete pod one. So what I will do, I will create a deployment. So I will go to cd manifest that directory we are keeping, right, for our scripts. So now I will say ls and let me remove all these files. I think all these files I already have on my repository. Config ds.yaml is there. ds.yaml. Okay, I will keep this. So what I will do, I will create a I will create kubectl create. I will create a deployment, and the name of the deployment I will say nginx deployment. And what I will do, I will say that image is nginx, okay, and number of replicas, it is 3. Okay, I want to run 3 replicas. And what else I want? Replica equals to 3. And yeah, I think that's fine. And now I will run dry run equals to client minus o YAML. So this will be my YAML file. Let me put it into a file. So I'll say greater than, and I will call it as deploy.yaml file. Now what I will do, I will open this file, which is deploy.yaml file. And whatever I don't need, I will remove it. Container name, I will say nginx. Container, that's fine. You can keep anything. Label, I will put app equals to nginx app. This is the deployment label, but I will keep everything as nginx app. All right, so I'm creating a deployment now, which is having 3 replicas. So kubectl create -f deploy.yaml file. So this is created. Kubectl get all. So you can see there is again something wrong. Error image full. Oh, sorry. Image name is nginx. Kubectl and apply -f. No, if I say kubectl get all, so now new pods are getting created. I will remove this replica set. Kubectl and delete replica set, which is this one. Kubectl get pods. So 3 pods are running. Now let us see their IP address -o wide. So these are the IP addresses of my pod. Now see that problem which was curl. Okay, I need to see that one. So there was one fix for the issue which I had given, that if you want to access, so see, I'm able to access this with the IP address. So I have uploaded one video right yesterday, which is fixing this issue. So just walk through that, how it is happening now. Earlier when we tried that, at that time it was not able to access on the pod IP address. We were able to access it on that particular worker node. For example, if we are on worker node 2, so there we were able to run this command, but not on the master or other worker node. So that issue was fixed, and I already have a video, so you can just check that one. Right now, I want to create a service. So first service which I want to discuss is the ClusterIP service. So this service is the internal to the cluster network. Okay, means the service is available within the cluster only. Within the cluster only. Means if you want your database should be only accessible within the pod network, then you can use the ClusterIP service. Okay. All whatever type of service we are going to discuss, all are having the same features: endpoints, internal load balancer, etc. So now, how to create a service? So our deployment name, kubectl get deploy. So we will target this deploy. So you can create the service by using command or by using, excuse me, manifest file. So now here, this is my deployment name. Okay. nginx app. So I'll say kubectl expose, okay, kubectl expose command for the service. Expose the deployment, and the deployment name is nginx app. And if you don't mention the type of the service, by default, it is a ClusterIP service. Okay. So kubectl expose deployment, nginx deployment. So type, if you don't mention, that is fine for ClusterIP. If you mention, it will be the ClusterIP again. And now there is something called target port. Target port is called the containers port. See, my nginx application runs at port number 80, right? My nginx application runs at port number 80. So in that case, the port number 80 is the target port. So target port is containers port. And now my service is to access those ports, right? How they will access? Through some port number. So there is a mapping required between your service and the container port. So the port is the service port, which is mapped to the container or target port. So now my service is created. When you create a service like this, and you don't give the name, so you will see the service name is same as the service name is same as the deployment name, which I don't want. I want my service name should be different. See, its name is same as the deployment name. So what I will do, kubectl delete service and nginx and app service. Right, delete it. Now next is kubectl and I'll say kubectl same command, expose command, and now I will give the name of the service also. So I will name it as internal service. So this is exposed. Now if I say kubectl and get service, so now you can see now the service is created and the name of the service is internal service, right? And this is the IP address of my service, which is a fixed or static IP address. It will never change. Now, how it will be connected to my pods? Because I'm mentioning here deployment is nginx deployment. Now let me show you that one. If I say kubectl get pods minus -o void, so here you can see these all are my pods and these are the IP addresses of my pod. Now, if I say kubectl and describe my service, which is the internal service. So what will happen now? You can see there is something called endpoint. So these are the endpoint, which are nothing but these are the IP address and the port number, because we have port number port 80, right? Which is mapped to my target port. Now, this is the IP address of my service. Now, let us do one thing. See, consider I'm going to delete one of the any of this pod. Let me delete this. So it will create a new pod because of the deployment and replica set. And now after that, a new pod will be created. So new pod should be automatically becomes the part of my endpoint, right? So let us see. So if I say kubectl and delete pod and the pod name. So I'm deleting this pod. Pod got deleted. A new pod should be created. Now you can say so far not created. Okay, it will create. So it is getting created. Now new pod get created, which is having the IP address .74. Now, if I describe my service, so you can see 73 IP address is removed and 74 IP addresses automatically attached in the endpoint. So these endpoints are the reference where the actual traffic goes. So when you access through your service, so service is having one IP address. So if I say kubectl and get service, so you can see this is the IP address of my service. Now if I say curl and this IP address, so you can see I'm able to access the application. Why? Because this service is sending my traffic to the pods or pod IP addresses. Do you understand what I'm explaining here?
Yes, sir.
All right. Now, next thing is that now this service, the one which I have created, kubectl get service, which is a cluster IP service, right? And this service is only available within the cluster. Means if I go outside the cluster and if I try to access this, so I will not be able to access my application. Okay. So it is the main use cases for this is your database, your some private applications which you don't want to expose to external world. So those are basically comes under this cluster IP service. Now you can also create the service by using a YAML file. So how to create that? You can run this command, expose command, and dry run equals to client minus o YAML. Okay? So this will be your YAML file, and I would suggest that you try this by yourself. Put it into a YAML file, and then kubectl create minus f and create this service. Okay, so this thing you need to try by yourself. Now, let me delete this service. Kubectl delete service, and the service name is internal service. So I'm deleting this service. Now, service will not delete the pods. Service only deletes the service. Deployment will delete the replica set and the pods. Now, second type of service is uh, um, NodePort service. Okay. So this is a service if you want to access your application outside the cluster, like web application, right? Microservices, etc. Okay. So what it will do? It will just 1 second. All right. So it will be a, so what it will do, NodePort service. So if you want to access your application to the outside the world, then we use this NodePort service. So what it will do, it will expose port, you can say 30,000 to 32,767. Okay, so these ports are exposed to cluster level. Okay, which on the cluster level. So with the help of that, we can access our service externally with host IP address. Let us see what does it mean. Now I have that deployment, nginx app deployment. So I'll say kubectl. Actually, we will use the same command, this command, expose command. Right? And here I will name it as the external service. Type of the service is NodePort Service. Target port and container port is same. And now here, if I create this service now, so now service got created. Now if I say kubectl and get service, so now here you can see there is an IP address of my service. So if I say curl and this IP address, so I will get the nginx service because it is pointing to my deployment. Now here you can see my port 80 of my host machine, port 80 of my service is mapped to port number 31,112 port number. As I mentioned, this port number can be any number when you are using the expose command. It's a random number, but it will be within this range. So now the port, which is 3112, it is open. So it means if I say curl localhost, okay, so earlier what I was doing, I was using the IP address localhost colon and 3112. One more one. See, I'm able to access my application. Or if you want to see what I will do on any master, because service is available on the cluster level. So you can open the port number for any worker node or master node. So what I'll do that, I will just open a port forwarding and 30,000. I will open another port. I will say 127.0.0.1 and my host port number, I will put the same 31112 and it will be guest IP, means my virtual machine IP address, port number 31112, and I'll say okay. So now if I go here and if I go to my browser and if I open localhost colon 31112, so you can see my nginx application is up here, right? Now consider you are going to update this image with new version, or let me update with httpd image. So what I will do, kubectl. So my container name is nginx, okay, kubectl, and set image, right? Kubectl set image for my deployment, which is the nginx app deployment, and container name is nginx, and I want to give the Docker image httpt, which is a Docker image for Apache. So now if I say kubectl get pods, so new IP addresses will be, see, 9 seconds ago it is getting created, right? So new IP addresses are, so here when it is updating, let us refresh. Say it is showing this, right? So this is not yet updated, looks like. So it is creating. So because it depends that where my request goes. Now you can see it is updated with the it works. So this is the default page of HTTP. So now I am able to access my application, right? Which is I'm able to access this application, which is basically shows that my pod is updated. So in this case, I did not change end user point of view anything. I did not give a new IP address. I did not give, different port number. So this is something which is fixed. That is the purpose of service. So it will have a static IP address so that uh, you can basically use it for your domain, or you can map it with your domain. Is this point clear to you?
So, no, sir.
Huh?
Yeah.
You got it. Okay. Now, the next thing is that can we fix this port number? Because if I create a new service, it will have a different port. Yes, you can do it, but not with the command, but with the YAML file. So what I will do, I will kubectl and delete service, and I will delete my external service. So this service is deleted. Now we are having that expose command, and I will say --, try run equals to client minus OYAML, and I will put it into the NodePort.yaml file. Okay. So now this is created. Now I will open NodePort.yaml file. So here you can see we are having the target port and the service port. Here I can write the node port. Okay. And I need to give a number between that range 30,000 to 32,767. So here I will say 31,000. Okay. Now I will save this. Now I will create kubectl and create -f and nodeport.yaml. This is created. Kubectl get service. So you can see now it is having a port number which is 31,000. Now it means if I say curl localhost and 31,000, so you can see it gives me this output, right? Because my pods are running with the Apache HTTPD image now. All right, so this is how NodePort works. Now what I'll do, I will delete this service, kubectl delete service, and the service name is external service. Now, third type of service is load balancer service. What is load balancer? See, as I mentioned that service is having internal load balancer, right? Which is basically distribute the traffic to the pods. But consider you are having your own load balancer, or if you are having a load balancer on your cloud. Say an example, you are using a cluster in AWS, which is EKS cluster, or you are using Azure cluster, or you are using the GKE, which is the Google Kubernetes engine. So if you are using those clusters, right? So in that case, these cloud service providers, they are having their own load balancer. Okay, so if you create a AKS cluster or EKS cluster, so AWS is having load balancer service, application load balancer, right? Classic load balancer. Same way in AKS, there is load balancer. So if you want to use your pods or your service is to use that load balancer instead of internal load balancer, then you use the load balancer type of service. So load balancer service. When we use a load balancer, right? Instead of, or you can say when we use an external load balancer instead of service load balancer. Right? So you want to integrate your load balancer to your Kubernetes service, so that is possible. No, it is the similar command which we have done it here, expose command, right? So now the service name, you can give any name. I'm giving load balancer service, right? And this kind of command is more suitable for the cluster where you are having cloud-based environment. So I would suggest that when you try these things on the cloud-based environment, right? So there you can try these commands. Okay. Here it will be not that much meaningful because we don't have the load balancer. Now the type of the service is load balancer. Okay. So this command we write when we are using EKS or AKS, or you can also put something called external IP. Okay, external IP means your load balancer. For example, if I first let me just remove this and create this.
So what type of load balancer it will create? It will create a network load balancer or your application load balancer?
So it depends upon that where you are running. So for example, if you are running on AKS, right? So it will create a load balancer, not the application gateway load balancer. Okay. And if you are using the EKS, then it will create a normal classic load balancer. But we can when we use EKS, so we can specify whether we want the application load balancer or the classic load balancer. By default, it creates a classic one.
Okay.
So now, what happened? Spelling balance. Oh, balancer spelling is wrong. Right. So my load balancer service is created. Now, if I say, so load balancer service creates a NodePort service plus load balancer board. kubectl get service. So now here you can see my load balancer service is created. This is the IP address. And now you can see this is external IP, which is my load balancer IP address. Because we don't have any load balancer at this moment. So that is why it will be in the pending, and it will be always in the pending state. So what I want to do, I want to replace this with, consider you are having a load balancer IP address. So that also we can do. So now let me do one thing, kubectl and delete service, which is the load balancer service. Okay. So I'm deleting this service. Now, next what I want to do, same thing, same command, and I will put here the external load balancer IP address. If you have, I'm giving some dummy one, say 200.10.10.10. Okay, something. Now, if I say kubectl get service, so you can see now external IP address. So this is my load balancer IP address. Okay, so this is my load balancer, and also it is having a node port. See, there's a port number. So Now, next is that if I say curl and this IP address 200.10.10, so even though it's a dummy, but we will be able to access our application. Right? So, but in real time, it will be actual load balancer IP address. So this is the third type of service. So we have discussed ClusterIP, which is within a cluster. NodePort with the host machine IP address, you can access your application. And third one is load balancer IP address. So load balancer is basically your external load balancer. It could be on your EKS, AKS, or if you already have some load balancer IP address, you can specify that also. Right. And this is all about the services also. Now, if I say kubectl get service, let me delete this service, kubectl delete service, which is the load balancer service. And how to create with the YAML file, that you need to try by yourself. --, try run equals to client minus o YAML and then create it. That way also you can have your load balancer service. Now let me discuss about one more concept, which is called ingress controller. Okay. Ingress controller. So what is ingress controller? Now, whenever you want to access your application externally, you need a NodePort or load balancer type of service, right? But you don't want to directly access your service through your IP addresses. You want to create cluster IP services which are internal to the pod network, and you want to create a ingress controller which will point to these services and helps them to expose externally. Okay, let me just show you in this way. For example, if I go here, so right, something like this. So you want to access your application externally, right? But you don't want to give the or internet, and you don't want to expose your services as a NodePort service because these are internally defined but access externally. Only one public IP address is required. See, if there are, say an example, 10 services which is exposed externally, maybe you can use different port number. Or if you are accessing with the load balancer services, then you are having different public IP addresses, and IP addresses are not free of cost. You need to pay as per your requirement. You just need to pay whatever you are using the public IP addresses. So that is why what you can do, you can have one public IP address, but under that there are many services which are defined, like your uh, your cluster service 1, cluster service 2, cluster IP service 3, and all are accessible by using certain rules. Okay. How? What are the rules? Rules will be something like this. I have my service for example, my service is KMIT courses.com, right? And I want kmitcourses.com / if I say blogs, so it will go to the blogs. I want KMIT courses / news, so it will go to the news service. Blog is a service, news is a service, something like that I want to do. Okay, now let us see how we can achieve this. So first of all, we need to install the Ingress controller. Now so what I'll do here, let me first check kubectl get, or let me delete the deployment. Delete deployment -. So that deployment is deleted, replica set will be deleted, pods will be deleted. Now what I will do, here I will say kubectl and run. I will call a pod as news pod, and with the Docker image, I will use the same, say nginx. Same way, I will create another pod with the Tomcat, and I will call it as a mail pod. Okay, 2 pods get created. Now I want to create a service, one for news pod and second is for the mail pod, and both are the ClusterIP services. So I'll say kubectl and expose, right? Kubectl expose, and my pod, which is the news pod, and name of the service I will say news service, and type is ClusterIP by default, and target port is also optional. I'm saying pointing to port number 80. This is my one service. Now second one is service which is pointing to the mail pod, right? And this is a mail service, and Tomcat runs at port number 8080. Right? So 2 services I have created. Now I need to download and install Ingress controller. I'm going to use Ingress controller, which is nginx. Okay, so let me just go back to my notes. So I will copy this and I will run it. So there is a YAML file. On the basis of this YAML file, Ingress controller related pods, services, everything get created. Now, if I say kubectl and get namespace, actually we will talk about the namespace later, but here it is required. So there is a new namespace get created which is called Ingress nginx. Now, if I say kubectl and get service under the namespace which is Ingress nginx. So there is a service which is called this is the service which is a NodePort service, and it is pointing to port number this 443. This is HTTP and this is HTTPS 443. Okay. Okay, this is fine. Now what I will do, I will create a YAML file. I will explain this. So I'll say ingress.yaml file. Now here I will use all this ingress. The name of the ingress is, I'll say something KMIT ingress, and I'm using nginx, right? And I'm saying whenever someone says a path /news, in the background, it will go to my service, which is the news service, which runs at port number 80. And if someone says Tomcat, not Tomcat, mail, Then in the background, it will go to my Tomcat service, which is named as mail service at port number 8080. Okay. So let us see what it will do. So now let me save this. Now if I say kubectl and create -f ingress.yaml. Right? So what it will do, it will create a ingress. Now you can see kubectl get ingress. So you can see that there is one ingress is running, right, which is for HTTP only. Okay. Now I will take this port number. Let me just open that port also. I will go here, right, and where I have opened settings, I think into the network adapter 1 port forwarding. I will add one more to my localhost 127.0.0.1. Okay. This port number, which is pointing to this port. Now what I will do, I will go to my localhost colon and that port number. So when I run it, it is saying not found because I need to give the service name. If I say /news, it will go to the nginx. And if I say /mail, it will go to the Tomcat service. Okay. So this way, right? So this way we can basically create the services and we can put it under a ingress controller. And with the help of the ingress controller, now there is single IP address, and with that IP address we can access our application by / the service name. Like it will be easy also. For example, you are using Google, right? So google.com/mail if I say, and /news /YouTube. So it will be easy to remember for you also. So that is how we use the ingress controller. Is it clear to you?
Yes, sir. Clear.
Good, good. Right. Okay, so that is all about the services. And all the nodes and everything is here. Now let me delete this namespace, or what we can do, we can just that URL instead of apply, I will say delete. So what it will do, it will delete all the things which it has created for the ingress controller. Okay, so service part is ended here. Our next topic is storage. Okay, so let me first give a brief about what is storage. Now let us so I think for today this will be enough, right? Otherwise it will be overloaded for you.
Yes, sir.
Storage part we will discuss tomorrow.
Sure.
So okay, so once you get the time, please revise this.
Definitely.
See you tomorrow then. Bye bye.
Okay, sir. Bye.